Hello, and welcome back to the Encryption Edge, your source for in-depth discussion in cryptography, cybersecurity strategy, and the technologies reshaping our world. I'm White Hackathorn, and in this part two of our post-quantum cryptography discussion with Parna, our security architect and PQC advisor, we're going to kind of pick up where we left off, diving deeper into realities of post-quantum readiness, and then we'll shift to the listeners' questions and just go through what people are actually asking and kind of create a plan for what's next. So, starting where we left off, diving deeper into the verticals, could you share your insights on how specific industries face unique challenges implementing PQC, and especially when considering legacy systems or hybrid cloud environments?
Yeah, sure. So let's take an example of finance industry. So finance industry not only face regulatory pressure but also operational complexities. Legacy mainframes, diverse client endpoints, and complex multi-layered authentication are all dependent on classical cryptography at this point. And transitioning this environment requires a phased approach, starting with crypto inventory assessments and hybrid deployments that blends classical and your PQC algorithms to maintain interoperability. And if I take another example of healthcare, so healthcare's challenge is data longevity and regulatory compliance like HIPAA or GDPR. So patients' records must remain confidential for decades, and health IoT devices often have limited update capabilities. So this calls for PQC integration into medical devices, certification, and your firmware updates pipeline well ahead of standard expiration. And if you take an example of government and critical infrastructure operate under high security and compliance constraints, so they need to participate actively, I would say, in standard development and implement hardware root of trust upgrades like PQC enabled hardware security modules or HSMs, and rigorously test migration scenarios in lab environments to avoid any operational disruption.
Yeah, so the NIST PQC standardization process is kind of well underway. Can you walk us through the latest status, the algorithm selections, and the implications of the chosen algorithms for any real world implementations?
Yeah, sure. So NIST has selected Crystal Kyber, a lattice based for key encapsulation mechanism, that is KM, or also known as MLKEM, and Dilithium, Falcon, and Pings Plus for digital signatures, and the latest one which we have got in March 2025, that is HQC for code based public key encryption scheme. So the MLKEM offers, or the Crystal Kyber offers strong security with relatively efficient performance and reasonable key sizes, making it a leading candidate for a TLS key exchange. Dilithium, or MLDSA, and Falcon provides quantum resistant signatures with trade-offs. Dilithium favors simplicity and auditability, and the Falcon offers, I would say, a smaller signature but requires floating point operations that may not be suitable for all embedded environments. Coming to Fix Plus, that is a hash based scheme with larger signatures but is notable for its conservative security assumptions. And the latest one, that is the HQC, Quasi Cyclic, I hope I am pronouncing it correctly, is a code based public key encryption scheme designed to provide security against attacks by both classical and quantum computers. And from the migration standpoint, organizations won't be able to, flip a switch to PQC overnight. They will need to adopt a hybrid secure cryptographic approach, which means running the quantum resistance algorithms alongside your classical ones like your RSA or DSA or ECC to ensure backward compatibility during the transition phase. So this means updating protocol stacks such as your TLS 1.3 to support dual key exchange and signature mechanisms. But here's the catch, it does not stop at software. So, the entire supporting ecosystem, that is your hardware security modules, that is your certificate lifecycle management platforms, and your certificate authorities must be ready to handle the increased key and signature sizes that come with PQC. So, performance, latency, and interoperability all become a part of this whole equation when you are planning for a PQC transition.
Okay, so let's get sort of a practical look at this. For an enterprise beginning the migration, what are the key steps and the operational pitfalls that you would highlight?
Okay. Firstly, a comprehensive cryptographic inventory that is a very critical part to have for your environment. Identify all your certificates and key usage, their expiry, their renewal cycle, and the trust chain. So many organizations underestimate the sheer scope. And next, we have to build a migration framework that is aligned with business risk and technical feasibility. That means prioritizing critical systems that hold long lived secrets or sensitive data or have the highest exposure. Planning must include mass revocation and reissuance strategies because legacy PKI systems may not scale or automate these tasks well. A key operational pitfall is insufficient staff expertise and fragmented one ownership. So, PQC migration requires cross team collaboration. Your security architects, your PK admins, your DevOps teams, your vendor partners, and your compliance officer, and whoever other relatable teams. So, automation tools are your best friend for PQC transition, and platforms like Such Secure Manager can um, orchestrate discovery for enrollment and automate provisioning of PQC certificates across your heterogeneous environment. So, without automation, manual migration is error prone and unsustainable. So, finally, ongoing monitoring and health checkups post migration are essential to ensure there is no fallback and there is no deprecated algorithms occurs that the system in interoperability is maintained.
Yeah, okay. So it does seem like the new environment for PQC and just managing certificates is just going to be unmanageable without some of those systems, like a certificate lifecycle management system, and just making
Yeah,
sure that you are able to provision for those PQC certificates. But how
right.
important is industry collaboration? So, what role do you see working groups and vendor partnerships playing in the actual PQC readiness?
So I think the collaboration is extremely important. The cryptographic changes are happening fast, and no single organization has all the answers since it's new for everybody. And industry consortiums, standard bodies, and vendor coalitions provide platforms to share best practices, develop interoperable standards, and push software and hardware vendors towards timely PQC support. So, takeaways from our recent government directives and our regulatory frameworks like NIST 2 emphasizes the need for documented PQC strategies and risk assessment. This regulatory pressure is accelerating adoption cycles, and vendor partnerships matter because PQC support must extend across the entire technology stack, your networking gear, your cloud platforms, endpoint security, your DevOps tools, and your certificate authorities. So, open source projects like OpenSSL 3.0 incorporating PQC primitives pave the way, but enterprise grade support requires rigorous validation, your security audits, and your performance tuning.
Okay, so that's really interesting. Um, but all right, let's sort of switch gears. Let's do sort of a rapid fire questionnaire, questions from our audience, and then I have a couple for you as well. So we'll go through those really quickly, and then that'll be it for our episode. So, what's a
Oh,
common
okay.
sort of misstep in PQC adoption that seasoned security teams will still make?
Underestimating the complexity of certificate lifecycle automation and mass revocation readiness.
Okay. So, quantum computing timelines are often debated. What's your professional stance on that?
We are in a cryptographic race, and the quantum threat is near enough. That proactive migration is a must, and it's no longer if, but when quantum computers will force algorithm deprecation.
Okay. And a question from the audience. Someone asked, for cryptographic hardware like HSMs, what is the current state of PQC support for that?
It's emerging but immature, but I know many vendors who have already established their PQC capable hardware security modules. So, hardware security modules, vendors are developing PQC capable modules, but integration into existing HSM ecosystem and fifth certification will make some time for few of the vendors. But in the meantime, hybrid key management in software and middleware layer is essential.
Okay. So, Parna, any final strategic advice for C-suite executives and security leaders in terms of moving towards PQC?
My advice would be make PQC readiness a board level priority. Invest in crypto agility, in automation, in training your staff now, and start pilot migration on non-critical systems, and leverage the expert advisory services. The cost and the risk of waiting are exponentially greater than the proactive preparation.
All right, cool. Thank you for the thorough explanations and explorations of the PQC readiness, Parna. That is going to be it for today's episode on the encryption edge. Post-quantum cryptography isn't just a theory anymore. It's starting to move fast, and it's going to change how we handle encryption across the board. It's important to stay up to date with everything PQC. If you guys have any questions or topic ideas that you'd like us to cover, please send us an email at info@encryptionconsulting.com or leave us a comment if you're listening over on YouTube. Until next time, stay secure.